Hello, today is the 24th day of the 30 days of code challenge. The name of the challenge is more linked lists. Let's understand the problem statement. We have a node class. It's provided to us. Okay. It has an integer data. Okay. And next, the points another node, the next node. Okay. And we have a remove duplicates function. It takes a point to the head, so the first element of our linked list. Okay, we need to complete this function, and this function should delete duplicate nodes. Okay, and we are going to return the new head. Okay, so we have a side note here. It says that head can be null, so there can be empty linked lists. We are going to consider this fact. Okay, so okay, this causes problem. So consider the fact that we have an empty linked list if it is none. So then return return none. Okay, so it's empty linked list. Empty linked lists. Okay, linked lists. It's abbreviate is this as LL double L. Okay, so so we need to remove duplicates, but in order to remove that, we need to compare something with another thing. So let me open this paint. Okay, so let's say this is our linked list, and okay, so there's also an end node here. The linked list always is in non-decreasing order, so it either increases or it all elements are equal. Okay, so we have a non-decreasing order. It's non-decreasing. We will denote this like this. Upright pointing arrow. Okay, so upright pointing arrow. Okay, so we have a linked list here. The first element is 1, second is 1, third also 1, and the last element is 2. So in order to remove the duplicates, we need to compare two nodes that is sequential. So these nodes are sequential, these two also sequential, these two also sequential. So we are going to denote our first node as current and the next node as next. Okay, so our current node is head first. So we are going to ask why our current next is not known. Then go to the while loop. Okay, so say if our current next is not known, if there is a node after the current node, then we are going to do something. Okay, let's do something here. And we are saying current dot next is our next node. As we know, there is a node after the current node. So if current dot data is equal to next dot data, then if it is like this, if current data is 1 also and next data is 1, then we are going to catch this node like this, and we are going to point the pointer of the current node to this node. Okay, how do we know the pointer of this node? We know the next node, and the next pointer of the next node points to this node. Yeah, so we are going to write current dot next is next node next nodes next pointer. Okay, so right now we are pointing the third node. Okay, so our new linked list will be like this: 1, 1, 2. Okay, so our current is this one, current. Okay, and we say, okay, our if is done, then let's assume it goes to the next iteration. In the next iteration, as we are not changing the current node, it also compares these two values. If they are equal, then we are going to erase this pointer and we are going to point this one. Okay, we erased second node. So in this situation, in the next iteration, we are comparing these two nodes. If they are not equal, then we are going to, if they are not equal, we are going to change the current node. Current dot next. Okay, so our new link this is going to like this. and our new current is this one. Okay. The current next is not known. It is none right now because it's the end of the linked list. So we are not going to enter the while loop, and we are going to return the head. Okay, let's run this code. Run. Okay, sample test cases are passed. Submit this code. Great, we have solved this problem. Thank you for watching this video. See you in the next video. Bye.